Okay, the break is now over. Let's be able to do the questions. So here we're having the symbols here. Then it's saying, the question is saying, which is A, to which period of the periodic table do these elements belong? Okay, so we're having here, let's be able first to characterize or to categorize them, like name by name, be able to identify them. Okay, so the first one, this is lithium. Then we're also going to write the proton number to help us know the period. Okay, so this is what lithium, and lithium it is having 3. The proton number is 3. Okay, then we're having beryllium. Beryllium it is having 4 as the proton number. We're having boron, which is having 5 as the proton number. We're having carbon, which is having 6 as the proton number. We are having nitrogen is having 7 as the proton number. Oxygen is having 8. This is fluorine, it is having 9. And this is what neon, it is having 10. Okay, so now being able to categorize them, being able to identify each one by name and also the proton number. Let's actually find out which period. So we're just going to use the first one, which should be able to help us know all of them. Okay, so we come to lithium. We say this is the proton number. The first shell, it is supposed to have 2 electrons. Okay, the next 2 minus 3 minus 2, it is going to give us 1. Meaning the second shell is going to have what? 1 electron. Meaning making the total proton number. Then let's count how many shells do we have. We're having 1, 2. Meaning these elements, these whole elements, all of them, they belong to period 2 of the periodic table. Hence what the answer is going to be period 2. Let's hope you all got that correct. Okay, even though you also try out all these, you're going to find it's going to give you to say each one, the number of shells will be 2. Okay, we come to B. What happens to the number of shells across the period shown above? Okay, so what happens to the number of shells across the period shown above? Okay, so here then we can answer this. What happens? We should be able to categorize them into elements, metalloids and non-metals. Metals, metalloids and non-metals. So this is group 1. This is from group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. These are the group numbers. Group 1 to group 3, this is 1, 2, 3. They are metals. Okay, they are metals. Then we come to this is group 1, group 2, group 3. Group 4, which is carbon, here it is a metalloid. Then we're having group 7, this is group 5, 6, 7. These are non-metals. Then we come to what? Normal gases. Okay. So with these ones, they are what? Their number of shells is going to remain what? The same. Okay. So their number of shells won't change, to still remain the same, exactly the way with what? The way it is. Okay. So here, let's hope we're all writing. Let's be able to write the answer. So the answer is going to be, which is we're writing for B now, it is going to be the number of shells remain the same. The number of shells remained the same. Okay. So meaning here the number of shells in these remain the same. We go to C. C says answer the following question using only the elements shown in the table, which is B4.1. And the question we're having I to say which 2 elements would form an ionic compound. Okay. So with this I didn't really mention them. We have mostly 3 types of compounds. We have ionic compound, we have covalent compound, and we have metallic compound. Ionic compound is formed when a metal and a non-metal mix together. Let's say for instance potassium, which is a metal, and oxygen, which is a non-metal, actually come together. Mostly potassium reacts with chlorine mostly. So we put them together, they're going to form an ionic bond. Then a metallic bond, this is when metals meet. Let's say a metal and a metal actually share electrons. Okay. Then covalent bond, it is when non-metals are reacting to each other. Okay, so those are the 3 types of bonds you should take into consideration. But now let's mostly pay attention to ionic bond, which is what an atom and a metal and a non-metal actually sharing electrons. Okay, so here let's be able to identify which one is a metal. So you should just follow the group number. the non-metals. Then this is number 5, 6, 7. These are non-metals. So let's mostly pay attention to this. Okay. So this is lithium. If lithium was to what was to act with, if lithium was to be was to share electrons with oxygen, it would form a what? An ionic bond. So meaning here we're going to get a metal from these three and a non-metal from these three. So we're going to go for lithium and what? And oxygen. Henceforth our answer, which is Ci, it is going to be lithium okay, lithium and oxygen. Okay. So lithium and oxygen, when they react, are going to form an ionic bond because lithium is a metal, oxygen is a non-metal. Okay, we go to C2, it says, which element has a valency of 3? Remember, we said the valency. This is the number of electrons that are on the last shell on the what? On the energy level shell. It's actually known as that. Okay? So here we are first going to look at, again, this is the periodic table we're using right now. So it's saying which element has a valency of 3, meaning on its last shell it is having what? 3. So let's configure this. Okay, so 3, the first shell is going to have 2, then it's going to remain with 1, meaning the second shell is going to have 1. So meaning this is not what? The valency won't be 3 but 1. We go to beryllium, it is saying it is having 4, meaning the first shell is going to have 2 and the second shell 2. So no. We go to boron, which is 5. The first shell is going to have 2 and the second shell is going to have 3. Henceforth it stands as our answer. So here we are going to say which element has a valency of 3. So it is what? It is boron. Boron. Okay, we come to C3. Okay. C3 says, which element has allotropes? Which element has allotropes? Okay. So here when we look at the element that has allotropes, we are going to look at mostly the element which actually has the ability to bind itself with other elements. And that element is what? Is carbon. Henceforth, carbon is the what? It is the allotrope. Because it has the ability to what? To bind itself with other elements. That is what? That is an allotrope, which it is able to bind itself more with other elements or change itself but it's still the same element. Okay? So it reacts more by changing itself but it still remains the same element, that is carbon. Henceforth our answer is going to be carbon. Okay, so these are the answers. Let's hope you all got them correctly. Okay, so another thing you can take note, or the easiest way to know about the periodic table, just want to say these elements or the proton number of the periodic table are in the periodic table.